Hello and good evening, everyone. Today I am speaking to a solar physicist. It's Valentina Zharkova. I spoke to her, I think it's now more than a year ago already. And last time we went through the details of her analysis of principal components on the sun and the oscillator and things of that sort. And today we're going to talk a little bit about that, but also an interesting paper that she wrote about the link between solar activity and volcanic activity. So Valentina, welcome.
Hi. Yes. So just reminder where we stand, where we're working. So we're speaking about solar magnetic field and solar activity and impact of solar radiation on terrestrial environment. So mostly the measure of solar activity was use sunspots. So this is our sun, orange circle, and this dark spot called sunspots, which are close up shown at the bottom under the circle. So these are sunspot umbras and penumbras around. And it turned out that the number of sunspots varies every 11 years. And the index defined by average sunspot number called as current solar activity index, which is shown here, showing the number of sunspot in this bottom plot from 1870 until 2010. So this is average sunspot number, which shows maximum, minimum between cycles, and on the top, I apologize.
No, not an issue.
I need to switch off. I have two telephones. One is switched off and another is not.
Okay. Well, we wait for the telephone over there, and thank you everyone for listening. Please subscribe, please like, please share this on Twitter, Facebook. You're getting a free lecture on solar activity.
Yes. And the top, the butterfly diagram. So the sunspot are formed somewhere latitude 30 plus minus 30 northern and southern hemisphere. And over the solar cycle, they migrate towards the equator, and the next cycle repeats again. So this was until 2012, probably, or maybe even earlier, 2010. What are the sunspots? The sunspots are actually the location where magnetic flux tubes are embedded into the solar surface. So are shown in here. So S and N show the magnetic polarity in the sunspots. In reality, it is this loop which is embedded into the solar surface, which we seen at the orange sun. So we seen orange surface is the solar photosphere, and the sunspot places the roots where these magnetic loops are embedded. So basically, what sunspot reflect how many magnetic loops are on the solar surface. As soon as we got this understanding, we suddenly realized that magnetic field in sunspot is very high, 1,000 times higher than the background magnetic field, and they almost appear in pairs because magnetic loop always has one is southern polarity and another has northern polarity. So they should appear in pairs. So it become understandable. And normally, all sunspots of the same hemisphere have the same magnetic configuration. So, as I said, they change in their occurrence according to the solar activity. So, if hard X-ray in soft X-rays, when sun is not active, there is no much active region on the solar surface. But when we come to the bottom, like 1999, solar activity increased. You see that everywhere you see active regions at the tens, if not hundreds of those magnetic loops, which ignite each other and send the radiation to the interplanetary space. So this is what was solar activity is about. And how it works, to explain you briefly, it works like a dynamo machine. The simplest dynamo, you have this the thing children play which you put top. I don't know how it is called in English, but when you put very quickly from the
It's not a
top, it
it's not
starts
a
turning.
coil, but it's a coil or a spring or something.
Yes, yes,
Yeah.
exactly. And if you put this coil high enough, it can swap and stand on the top of the coil if the energy high.
You're talking of, yes, I know now
This
which
is the
that's the way. Yes.
I've forgotten how it is called. You will
Mhm.
remind me by the end of the lecture. But this is the principle of dynamo. But on the sun, this electromagnetic dynamo works. But it works in the similar principle. So first, at the minimum, in one minimum, the whole background magnetic field has northern polarity and in the north, and southern polarity in the south, and no magnetic loops whatsoever. So this is the general magnetic field of the sun along the equator, and this is it. Then you start moving to the solar activity, because sun rotates not like a solid body, but it is less gas um, body. So the equator rotates quicker than the poles. So it's called differential rotation. And because of this, the magnetic field, which was nicely separated north and south, during maximum, the magnetic field started migrating. The southern polarity from the south migrates to the north, and northern polarity to the south. And during the maximum, what you have hundreds of those magnetic loops. Sometimes the poles can have polarity, nearly the same polarity. They can have both north, because the migration of this magnetic field. And after they pass the maximum towards the next minimum, what happens? They change the polarity. Then in the north, the magnetic field, background magnetic field, has southern polarity, and the south has northern polarity. And then another 11 years, again, happens the same. So this is
What
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 people
what
manage.
drives that? What drives the oscillations in the sun?
It is solar dynamo, the same
Dynamo.
mechanism, electromagnetic solar dynamo. So it is
Okay.
exchange of electromagnetic force. So basically, this background field, when it is in minimum, at the same time, at the bottom of um, solar convective zone, there is formed millions of those magnetic loops, and they travel from all this time, from minimum to maximum, they travel to the surface. The closer the sun is to the maximum, the more active region or the magnetic loops appear on the surface. So they appear, and what they do, because the rotation is not equal in the equator and the lower latitudes. So this loop started twisting around and forming a lot of active regions. So let me, if I have show somewhere here. So they form active regions. So here the active region formed in there. So they twist, the magnetic loop twists around and form huge amount of active region, and this is caused increased solar activity, increased radiation, which comes to the Earth and other planets.
Mm.
Let me see if I have we done this automated detection, which was my job for 3 years in European project. This is why I got into the subject of solar activity. But here it is. So what we discovered, it was paper after we done this European grant for automated detection. We discovered at the bottom is the leading polarity of sunspot number. Blue is northern and orange is southern. And on the top is solar background magnetic field. So remember, these loops are floating or embedded into the surface. So what we have where they embedded. On top is this background where they embedded, like the soil of the sun, but it is not soil, it is plasma.
Yeah.
So what you can see, that magnetic field of the soil, of the background field, has opposite polarity than leading polarity of sunspots. What we discovered that basically this magnetic field of the sun defines the actually behavior of sunspots. What we figure out in this paper, and then we look the sticks in 1976 done the same, we found this anti-correlation between background field and sunspots and decided that probably it's much easier to analyze the background field because it's a huge amount of this field. Remember, the background field covers the whole solar disk, which is 1024 by 1024 pixels. While
Yeah.
sunspot has probably maximum 20, maximum 100 pixels out of this few 100,000 pixels on the sun.
So
So the error,
you'd study the anti-correlation that gives you an indication then of the sunspot activity.
yes,
Okay.
yes. What we found that actually this background field has the upper hand. It shows where the sunspot could appear on the surface and how can they migrate. Remember, the sunspot appear on the surface and they need to migrate to the equator. And this route is prescribed to them by this background magnetic field. Okay?
Interesting.
Yeah. So we simply take understanding of solar activity like to the next step. So we use solar sunspots as definition of solar activity, but they do not give enough information. The idea of doing this automated feature recognition, like in this catalog, we done catalog of sunspots, which we done how many of those? There were about 100,000 of sunspots detected. Everything you can imagine, we detect from this sunspot. We
So
can search them.
at any given moment, how many sunspots are there on the sun, like today or
Well, they
tomorrow?
changing depending when during the maximum or during minimum. Sometimes can be maximum number in the last cycle was in 161. It was maximum sunspots per uh, at the maximum solar activity. Normally, it's much lower, and some cycles could be higher. Now, cycles are not very powerful, so the number is between 100 and 200. But in cycle 2019, the number were about 400 or 600 of
Okay.
sunspots. So it depends on the cycle. But what we discovered, we have all this data, all the catalog. We tried to introduce the automated classification, and we couldn't do it better than people did it using manual classification because they put a lot of personalized views by observers. While when you have digital image, you can't do personalized because you're restricted by the accuracy of your digital image.
Yeah.
So this is what we found that we can improve sunspot index, but we thought, if sunspot occurrences is modulated by background field, why don't we look at the background magnetic field? This is how we arrived doing this principal component analysis. So when we
Okay.
look at magnetic field, we discovered um, the curve like in the white light. We discovered many different components and we couldn't understand what we got. And then we thought how we can separate these components. We thought, oh, how they did in electromagnetic radiation in the light. They put white light onto the prism, glass prism, and glass prism, because of different diffraction, split this one white light into all the components from red to indigo, right?
Yeah.
So we need to find what can act as a glass prism on the magnetic field, right? So what we found that principal component analysis can act on the magnetic field data as this glass prism acts on the white light, splitting them into the components.
So the eigenvectors would tell you then the components.
Yeah,
Okay.
exactly.
Oh,
So what we managed to find own oscillations of magnetic field, and instead of having very difficult distribution of magnetic field, we can split them into different components. So what we did, we first find eigenvalues of whole magnetic field, background field. So we forgot about sunspot. We took the data of Wilcox Solar Observatory, which has low resolution magnetic field. The pixel is size is 20 arc seconds, so we can see even sunspot. If sunspot, which normally its size is about 1 arc second, maximum 2, it has a magnetic field 1000 Gauss, but in the pixel in this observatory is split in the 20 by 20 arc seconds. It's seen only as about 4 Gauss. So we, in this low resolution observations, we basically removed sunspots. We used only the background field. And what we discovered with this, we got eigenvalue. Eigenvalues are the frequency of own oscillations of the sun. We discovered here, so this is eigenvalue number on against the variance of the data covering this. So we found that my principal components, these two, come in pairs. You have one pair with about 39% of data variance covered by them. Then we have another pair with about 9 plus 9, 18% of data variance covered by them. And then we have another two pairs which cover another processes. So when we found it, it was 2012. We didn't know what we found. We just look at them and thought, they come in pairs. Why do they come in pairs? We couldn't understand.
Yeah.
So we decided, and now we know, because we published already paper 2015, we managed to extract these pairs. This is the principal component which we extracted. We found that one is traveling from the northern hemisphere to the northern hemisphere, another traveling from the southern hemisphere still to the northern hemisphere. But they have a phase difference between them. So one of the components, you see the red component runs a bit faster ahead than the blue one, right?
But they're the
So
same period, yeah?
yes, and this is when these two curves met together, when they got the similar amplitude, this is the resonance happening, and this is why you have maximum of solar activity. And in this, where these two components meet, this hemisphere become most active. So in the cycle
It's
21, 23, the most
you,
active northern
just to
hemisphere.
clarify, you said resonance, or do you mean amplification? Actually, is it?
Yes,
Yeah.
it's amplification. The
Okay.
waves started interacting with each other and produce more solar activity. It means that these loops become touching each other, produce shortcuts, solar flares, coronal mass ejection, produce a lot of activity. This
But
is where they happen.
what would happen, theoretically speaking, if they were in phase and actual resonance? Would that not be a
Uh,
dangerous situation?
they cannot be in phase completely because they have different, luckily they have different frequency and periods, slightly different. I will speak about it. But this is what happened when they're closer in phase, like in this maxima of solar activity. You have the maxima, you have few hundred sunspots on the surface, and this defines the maximum of solar activity. And then when they go, red curve runs away from the blue one, this is where they come, and here on this line there's a minimum of activity because this curve, these waves, one is still in the northern hemisphere and another is still in the southern hemisphere. Okay?
Yeah.
So these waves are traveling. So you see, and what we, so this is the data from the left hand side which we used. And on the right hand side, this is what we used for verification. So we didn't have this data. We started doing this from 2005, and by 2012 we managed to quantify these two curves. Basically, what we managed to do, we managed to find mathematical law from each principal component,
That's
for
a
blue one
Fourier
and
transform,
for
or
red one. Huh?
that's a Fourier curve, or what is?
No,
Maybe I
it is
just
simple
sine
cosine
cos.
function.
You know.
But as you see, these all the coefficients, um, this is the frequency, this is the amplitude, and we had 5 cosines. But what it turned out that the cos is actually a product of two cosines, and period or shift between the waves is also cosine function. So instead of having cosine here omega k, we have cosine b by cosine omega k. So this
Okay. Yeah.
was unpredictable, but the software allowed us to detect this. We don't get it from dynamo equations. So this was unusual. This is what we discovered after we quantified these principal components in here using Eureka software and the Hamiltonian method by Schmidt and Lipson. So then when we managed to do, it took only 5 series of 5 this complex cosine function. But what we managed to reproduce with this formula the principal components for cycle 24. So this is what we reproduce is our curve, red solid line, and dashed line is a real curve which we derived from the data. So as you can
And
see,
you didn't hindcast that. I mean, that is actually based on the prediction you made. Say, when is it? 2012, I think. I can't read the graph. 2010 or 25, or when it is.
yeah,
I
we
mean,
used
yeah,
until 25 and we predicted from 25 to 2012 for 7
yeah,
years, and they produced very accurate prediction. So this
interesting.
accuracy was about 97%, which we thought very good. And this is the point when we publish paper. This is when we
That was the
sitting
first
at
paper
that
that
time.
they rejected out of no grounds, or was that was one
But
afterwards? That was the paper that they rejected first.
no, this
No, no.
paper is published and never been rejected. It is
Okay.
published 2015. It is still there.
Yeah.
Not a
Oh,
problem.
okay. No, I'm
It was a
confusing it with the
different
one.
paper published 2019. We
Yeah.
come to that paper. This paper never been rejected. They uh, many people now confirm that the solar activity is reducing. But what we did when we got the formula, we could calculate now the magnetic field propagation to the cycle 25 and 26. And what we found that these two waves not simply come phase different, they come in antiphase, and especially in cycle 26. You see, the red wave comes maximum in the northern hemisphere, and the blue wave has minimum in the southern hemisphere. So basically, they are in antiphase. And if you calculate these components, if you add them together, what you will see that amplitude of these magnetic waves actually is reducing very dramatically. As
Yeah.
you see, it was here, it was number 600. It is arbitrary number defined by the principal component analysis, but it gives you the clue here about 600, and this one is about 200. So reduction by three times. So we wanted to understand what did we get. So far it was like mathematical exercise with magnetic field. So we needed to link this magnetic field to some parameters which are used by observers. And we thought the best thing to link it is average sunspot numbers. So what we did, we took this red curve average sunspot numbers at that time, cycle 21, 22, 23, and built on top is our summary curve. And we found, oh, look at that, our summary curve. So this is the curve. This is the summary curve with positive and negative polarity. If I use the modulus of this curve, reflect this negative to the positive one. Do you understand how I do it? So I
Yeah,
put
so
this
just like the
negative
absolute
to the
value. Yeah.
positive. So I get this one. I got
Mm.
the curves which define exactly the, oh, very closely the average sunspot number. So my modulus summary curve is our solar activity index, more or less.
Okay,
Even
so
here,
so the
when
conclusion from that would be that whenever there is sunspots, doesn't matter how many, there has to be solar activity.
yes,
Yeah,
exactly. If magnetic field is strong enough, it has to be solar activity.
yeah.
The sunspot is a reflection of solar activity. So it is only a small part of it because it reflects um, the main activity comes from active region and coronal mass ejection and flares. And sunspots are only roots in which these loops are sitting in the surface. So
Okay.
this is what we've done in 2015. And then we calculated the summary curve at the bottom for cycle 24, 25, which we are now, and 26. And what we discovered that solar activity has to decrease very dramatically in cycle 25 and especially 26 by 70% compared to the even cycle 24. This activity is
Yeah.
decreased. So we predicted that it will be decrease of solar activity type of Mount the minimum, which happened in 17th century.
Mm.
By now, since 2015, by now, the similar results were obtained by Kitiashvili. She used the same data and also obtained the reduction of magnetic field in this cycle. Abritka and Velasco Herrera, they used Bayesian method evaluating sunspots, and they obtained that reduction of sunspot will be also in cycle 25, 27. So, but in 2015, no one was predicted. So they look at us like we do in ERC, but nonetheless, it was very popular topic. We had
How does it feel
research
being proven correct?
and
How does it feel to be proven correct?
it feels great
Yeah, I
because
can
now
imagine.
we published another paper here, monthly notice 2022. Now we added cycle 24. So this is the observation of the cycle 24, and this is our curve. So we feel great because we confirm that basically background magnetic field is the one which defines appearance of solar activity. Also in that paper in 2022, we shown that other components, remember there were smaller variance component. This magnetic field in here is defined by dipole magnetic sources, north and
Okay.
south, and it defines about 67% of data standard deviation, or 39% by data variance. If we take the other pair of magnetic sources, they produce by quadruple magnetic sources, which are also formed in the sun, and they cover another 20% of the data. And then we added quadruple, sextuple, and octuple, and we shown that quadruple and sextuple, they actually define the flare activity. We found the very close correlation with the flare activity. So this published in this paper in 2022.
Okay,
So
that's interesting.
yeah, this is definitely principal component allowed us to define separate component of magnetic field and find the links of each component to separate magnetic events on the sun. So this was very educational and very interesting.
And
But
and
it took us
just
some.
Just for the listeners, I mean, principal components is basically noise reduction techniques. It's a facial recognition it uses it some that type of thing.
No, it is not noise reduction. It
No.
is actually very precise method. If anyone solve the second order differential wave equations, so it
Yeah.
is ordinary differential equation, normally defining the waves in the sun. So everyone knows that their solution defined by characteristic equation and always have this quadratic equation has two roots. And the roots of these quadratic equations are these eigenvalues.
Yeah.
So eigenvalues are precise numbers. So they're not approximate, they're precise. And
Okay. Yeah.
this is the beauty because the magnetic wave, the wave theory works with the eigenvalues as precise number. And this is why it is not pattern recognition, like you say, with artificial intelligence or any other method. This is the precise method. We only count the variance which is responsible for each component. But this is a very precise method. So this is
Okay.
not the artificial intelligence. This is not anything related to neural network or anything. This is the precise method. We calculate the covariance matrix and we find diagonal elements which minimize the covariance matrix and find the which variance responsible for each element on the diagonal. So this is how it is done. And
Okay.
my first year students of physics in astrophysics in Newcastle University, whom I taught, they can solve these equations very easily. This is the part of the study. Luckily, when I wrote this paper, I started teaching this module for waves in 2014. So obviously, writing the paper in 2015 was easier because I knew how it can be explained to the public.
Mm. Okay.
Okay.
Interesting.
So now we move back. So remember, we have a formula for this dipole magnetic field. We speak still about dipole. We didn't go for the quadruple. This is the data we used, shown by oval. And when we built summary curve for background magnetic field, this is what we found. We found that backwards in 17th century, we had little ice age with Maunder minimum, delta minimum. And then we were in the approach in 2015 to the modern Grand Solar Minimum, which was starting in 2020 and will be ended in 2053 when the cycle 27 is finished. When we look backwards, this is Wolf Grand Solar Minimum. Look backwards, it will be another Oort Grand Solar Minimum and many others. We did restoration up to back 5,000 backwards.
I wanted to ask you on the restoration. I mean, what proxy do you use for this? Because one argument I've heard from a friend of mine, is also a solar physicist, has been that the modern minimum took place during the time of, I think, Louis the 14th or 15th, the Sun King in France, and there was a story that they didn't count all the sunspots at the time. I mean, have you heard that before?
The proxy is this one. This is the formula we used. This is the formula.
Okay.
We used this formula. We didn't use anything. We used background magnetic field. We got the formula, and this is built from that formula, right?
Okay.
So whatever they say, no one can deny that the rivers were cold, the sunspots were minimal, but there were also minimal sunspot during Wolf minimum in here, and when you book backwards during Oort minimum and many others. So what we discovered, this so-called grand solar cycle. This is when the amplitude of cycle from 17th century to 21st comes through the maximum and come to the minimum again. You see that, yeah? And then
Yeah.
it will be next. This is the first modern Grand Solar Minimum, and then the next second modern Grand Solar Minimum will be 3000. Which one? 2003,
2300.
2375 up to 2415. It will be 4
Okay.
cycles, the next one.
Not anyone today will be alive to to
Yes,
verify
but
that.
we still leave the digital information so people can respond. I would leave, obviously, the formula for people, they can use it. So at the moment,
Sure.
we didn't make it public, this formula, but we have the numbers. I can leave the arrays for people to use, and they can use why this grand solar cycle was formed. Again, this result was reported in National Astronomy Meeting in Llandudno in 2015. So we had press release on the Royal Astronomical Society site and very wide coverage by the press in the world. So you can look. I can give you this link to this data. So then we compared some summary curve with observation before the cycle, before the telescope was observed. And when you look observation of large sunspot by Chinese, they actually put exactly on the curve where we predicted. And telescope was invented only somewhere here after 1630. So these are observations, visual observation by Chinese. There was no observation in these periods because severe disease in China, no observers. They were had actually, by that time, I will say it was an explosion of supernova, which caused a huge impact on the earth. And this is why all diseases, remember, they were plague, black
Black
something,
Death, yeah.
everything. This is what the beginning of 14th.
So every time there's a major solar activity, humans go a bit crazy and
It was not solar activity. It was
it's the
actually supernova
supernova.
elsewhere, somewhere, another star, which was very close towards us. I will mention about it. So this is what the previous grand solar cycle. So if you look at here, this is what we found prediction: Mount the minimum, Wolf minimum, Oort minimum. The only thing we do not have, they call this Spur minimum. This is the one. We don't have it. During Spur minimum, we have maximum here. And what we discovered, this is exactly when this supernova, Vela Junior, was exploded. It was exploded somewhere at this time, 1340 or something. And it was exploded in the southern latitude, about 55 degrees. It was at the distance 600 light years from us. It was very powerful. It is still one of the most powerful gamma ray sources, but in 14th century it was extremely powerful, and it produced very strong background radiation, which induced the error when the people calculated here the period or the time of biomass. So this red curve obtained from the isotope C14. For isotope, they need to know the background of radiation on the
Yeah.
Earth from any sources. So they assumed it was like a normal background we have now. Well, in reality, it was much stronger background caused by this Vela Junior, which gave them error of calculation of about 250 years. So this grand solar minimum actually should be Wolf minimum. So basically, they background
So
increased very dramatically because of Vela Junior, and they
so
made
the Vela Junior was offsetting whatever was taking place on the sun, basically.
it is not, yeah, it's offsetting absolutely everything,
Yeah.
because if Vela Junior was 100 light years closer to us, the Earth and Sun would stop exist. Basically,
Yeah.
they calculated that explosion of supernova at the distance lower than 500 light years destroys everything in the close surrounding about 100 light years. So we were lucky that
Ah,
it was only 600 light years, but it produced very strong background of the cosmic rays and radiation, and this is caused error in calculation in Spur minimum. If I will bring you, these are the years of all the minimums which we found very good correlation in
just for
here.
curiosity, I mean, what is the increase in the forcing then if there is a supernova? I mean, it
Pardon?
seems when there is a supernova, what is the increase in the forcing, the watts per meter squared? Do you have an idea?
Increases the gamma ray emission. So on the Earth, we had so much radiation, hard X-ray and gamma ray. They woke up, and this end of 14, beginning of 15th century, all the bacteria, all the ices on the Earth, and this is why we had so many diseases at that time.
Okay.
This plague, black black death, and everything. This is because we had huge radiation which woke up the many lands which were always frozen, all the bacteria. And these bacteria started developing on the earth and cause mass death. So
Okay. Interesting.
this is what happened at that time. And this confirms the diseases were in China, the diseases were in Mexico, and in Europe. So all this 14th and 15th century was fully actually covered by the diseases, because all these bacteria got on the surface and started flourishing. This is why people worried now about upcoming global warming, that the increase of the temperature can again woke up these spore of the bacteria which were hidden for 100,000 years, and then suddenly they can wake up and start working again. So this is, but imagine if we have very strong radiation. This supernova is only 600 light years. After that, the other two supernovas, which uh, detected by Tycho Brahe and others, they were 8,000 light years. They were 10,000 light years. So they were much far away. We see this radiation, but it doesn't affect our planet much. But this one was very close to us. And the here is the observation. When you look at that, on the top, it is the number of auroras observed in the 14 from 1450 until 1700. So we deliberately pick up all the aurora observations, and you can see that in the 15th century, the auroras were the highest ever observed. What it means that we have uninterrupted flux of energetic particles which produce gamma ray and hard X-rays coming bombarding the Earth. So you see the auroras were very high amplitude. They recorded auroras even in Spain and Portugal. At the moment, we see auroras on the north of Scotland and Finland. But
Yeah.
in 15th centuries, they observed it, they recorded it. They've seen it in Portugal and Spain. So
Okay. So
it's
you're quite confident, given the history, that that period that doesn't fit into your curve can be explained by this
yes,
the
it is.
supernova. Yeah.
They simply done. They didn't bother to explore what was the background. They just used the standard background, which
Okay.
can
I see.
have. So, and it never been actually questioned until we produced our curve, and we suddenly did not hit the Spur minimum. So nobody else was challenged because nobody else discovered any discrepancies, only us. So when we got these auroras coming so high, I look at the observations of the temperature. This is the temperature observations by different observers. Again, in these from 11 to 20th century. And look at this 15th, 16th century, 15th century. So normally when you have minimum, if there is spore minimum as they claim, during the minimum, the temperature normally drops up in the Earth. In the spore minimum, the temperature here, the red, this is the light, it has maximum. It corresponds to our grand maximum of grand solar cycle and not minimum. You see that?
Yeah.
It has maximum when it is between 1400 and 1500. Even if you look at the ice detected on the Greenland in here, this is Greenland ice, and this is ice in Antarctic with this one. So you can see that in the spur minimum in Antarctic, you had minimum ice, but in Greenland, because we have maximum at that time. Why? Because the supernova was on the very deep south, 55 degrees of south latitude. So it affected the southern part of the Earth, but
Ah.
not the northern part.
So there was a differential temperature over the Earth then?
Yes, of course.
Okay.
Of course, this is the thing. And this is what we believe, that what we found is actually very good verification that the solar activity has this grand solar cycle separated by grand solar minimum, because we've proven that it is there. And to explain you how this grand solar minimum works, here are the dynamo equations. Probably you don't want to see them.
Partial differential equations. Oh.
Yes,
I haven't solved them in a while, but I understand.
yes, we done this
somewhat.
in this paper 2015. We not only reproduce the observations of the magnetic field and reproduce this grand solar cycle, we manage now to simulate the similar magnetic field from the theoretical point of view. Nobody did it before. Normally they can simulate a couple of cycles maximum. We simulated 2000 years, so we used two layers solar interior, because we have two curves. So we assume that each curve is produced in different layer. One is in the bottom, close to the Takac line, and another is close to the solar surface. And by the way, people confirmed this from the helioseismic observations independently. So we did know they did observe. We assumed, and suddenly after we published, we discovered, oh, they observed it. So basically, what we produce this interference of two waves. And here, for explanation how this interference works, I put few slides from my lecture notes. So this is the formula for the resulting wave. You have own oscillation of the system, or oscillation one wave, and this is another wave. So the summary curve is defined, let's say, by two cosines. So if you put these two cosines, we apply the formula for difference of two cosines, which is equal to this one. What we got that the amplitude would be varying following this formula. This is the initial amplitude modulated by sine of difference of two frequencies divided by 2. And the total frequency of these waves will be half sum of the frequencies. So basically what you have interference to waves. So the original cycle, 11-year cycle, shown here with the blue line, these are your amplitude. But because amplitude affected by this sign, so you see amplitude is coming through maximum to minimum. So you have this envelope cycle, which we call grand solar cycle. And this is internal cycle, which is
Okay.
initial cycle.
So,
So
so the
it is
grad,
very clear described by the theory of wave interference. Right?
yeah. So you make the argument. I mean, it's just to sort of wrap my head around that equation that the envelope case is the function of the two interfering waves, basically.
Yes, it is difference
Yeah.
between their frequencies divided by, so the amplitude varies according to the sign of the difference of two frequencies.
Okay. Very interesting.
So, and this effect is well known effect in the wave theory, because if you have a piano at home and guy engineer comes to tune your piano, he comes with the fork and hit the button of your piano and hit the fork. If they sound on the same frequency, they have the same sound. But if the frequency close but slightly different, the he hears the beats. And I don't know if you ever heard, but sometimes 3 beats, sometimes 4, and it gives him the clue how he needs either to increase the tension or decrease the tension on your piano
Yeah.
button or the.
I mean, I think of earthquakes when I look at that again. When you have earthquakes, sometimes you have consecutive waves coming.
Oh yeah,
That
this
sort of thing.
is
They
a
look very
different. But
similar.
to explain, this
Yeah.
is nothing magical or inventful. This is basic theory of the
That's
wave
basic waves, basically. Well, I wouldn't
Yeah,
say
basic
basic, but
waves.
yeah.
And this now explain. Now we know that the waves should interfere. At the bottom is our curve, which we derived from the observations, summary curve, and the top, which we derived from the dipole dynamo waves in these two layers. So you see, we managed to reproduce pretty closely the waves like this and that. This one, which has like elongated with the maximum here and that. So we managed to reproduce pretty closely and hit pretty nicely the grand solar minima which appear, because we understand now the nature of the waves, and we don't have engineer who can tune the sun these waves stop beating. So the sun had this beating effect for 2.5 billion years, and it
So
brings like,
the sun has basically a little heartbeat. You also have
absolutely,
one beat
this
after
is
the
the
other. Yeah.
heartbeat of the sun. This is why
Yes.
we call the paper heartbeat of the sun.
Okay.
So after we done this one, we managed to reproduce, for example, number of sunspots observed during Mount the Minimum. It is here 1720, 1720, exactly. These are the butterfly diagram which we observe. 1700, this is the 1700. So basically, as soon as we derive the magnetic field parameters from our summary curve, our model started fitting the observations, and whatever your guy was saying that people did not observe, but why the model predicts so nicely what they did not manage observe. So basically what it says that the model predicts the observation, we obviously understand correctly how these observations are obtained.
Unless both the model and the observation is wrong.
Well,
Okay, but yes, no, fair enough. We're not in the
and this
17th
is
century.
the what will be in the upcoming grand solar cycle. So you see it lasts only 3 cycles, and this is cycle 26 when there is no sunspot visible, but cycle 25 and 27 it will have enough of sunspots, so it will be fine. So you want to see now what happened with the
With the volcano,
volcanic eruptions?
yeah, that was also what I'm curious about. The article you wrote where you said that, and this is really the first time I've heard of it, that the change in magnetic fields in the sun has the Earth, if I understand correctly, correcting its magnetic field, and that's sort of by volcanoes.
Yeah, we can come back.
Okay.
now the paper we published in archive and paper under review. I wouldn't tell you where, but we compared our sunspot numbers with our curve. So our curve is the green one, and red average sunspot numbers. And you can see from 1900, our curve fits pretty closely with the sunspot numbers. There's differences coming in early cycles, but we discussed it. It was difficult. There were no basically observations. What you see, observations basically absent would in there. People stop observing for about a few hundred years. They were sick. No one was interested. There were diseases and so on. But what we also shown in that there is a difference between magnetic field between activities shown by sunspots. It shows the toroidal magnetic field, which is shown on the right hand side, while the background
Toroidal is the rings again, yeah? And
toroidal is the magnetic field of these magnetic loops.
yeah.
Poloidal field is the field of the background of the
Okay.
like if you compare it is like a sea. So the sea defines the poloidal field or ocean on the earth.
So
So this
toroidal is,
is
I always thought it was a donut, wraps around the donut, basically.
no, it is not
Or
donut. It
it's
is
just
background field
background field. Okay.
everywhere, but it varies. Like on the left plot, well, the magnetic field of sunspots should vary like this one, despite they
Okay.
both coming through Grand Solar Minimum, but they have different appearances. So basically, curves should not completely coincide. So we've shown this in another paper. We'll come back, but we compared average sunspot number with the modulus summary curve, and we found that they have the same period, 10.7 period, which is normal period of solar cycle in the past 300 years. So these are the correlation, so on. I can bring you. So what we expect, if you have Grand Solar Minimum, your solar radiance, because no active regions appear, no sunspots, your activity is reduced. On the solar surface, radiation is reduced by 3 watt per meter. So it was restoration for Mount the Minimum by Lean et al. In 1995. During Mount the Minimum, the solar radiance coming to the Earth reduced by 3 watt per meter. It doesn't look very much, but it caused, on the right-hand side, temperature decrease by 1 degree. So average temperature on Earth decreased by 1 degree because of this small reduction of solar radiance.
And that 1 degree was enough to freeze the rivers and the Thames. And
yes,
okay.
it's not only 1 degree because of the sun. We would Schindel et al., for example, they managed to reproduce the surface temperature of Earth during globe after Mount the Minimum. So here the temperature at that time, 2001, there's no psychotic obsession that everything done by human. They did real science, and they shown that the decrease of the temperature, the maximum decrease of the temperature, was on some reason in the northern hemisphere, in the Northern America and in Europe. So this is what happened. Europe and North America went in deep freeze. Alpine glacier extended, sea ice crept south from Arctic, Danube and Thames River canals were frozen. So what they reckoned, the drop of the temperature was related to the dropped abundances of ozone created by reduced solar ultraviolet light in stratosphere, and what it caused. So less ozone causes planetary atmospheric wave. These are jets. They create giant wiggles of jet streams shown in the pictures. This is what we observed this year. We observed jet stream before the Christmas. Remember, we had 2 weeks of frost in the UK.
Yes, the
And we had
coldest in
the
40
jet
years or
stream,
something.
yes, a very strong jet stream in the United States when they had this blizzard, 3 weeks of snow and the northern Canada. This is exactly what have they predicted. This called North Atlantic Oscillation, and they referred it to the Maunder minimum, but now we entered the modern, and we only the third year of the modern, but it started showing already. With the more we progress, this will be much more obvious. So this caused unusual cold during Maunder minimum. So what is happening now? So we see here the number of spotless days in the whole observation of solar cycles. The green one is number spotless day in cycle 25, which we are now.
Yeah.
And you see that this cycle has very sharp curve, the sharpest curve for the whole observations. So the number of spotless day increases in cycle 25 compared cycle 10 and 24. They had delta minimum, so they were the highest increase. But the cycle 25 has much higher, so it shows it probably it's Grand Solar Minimum, similar like Maunder minimum. And this is taken from the official site from Royal Belgian Observatory. It is not my observation, it is official one. So
Interesting.
a steep, and these are the snow in July in Ukraine at different times. So snow started coming up early in 2021, but the most apocalyptic was snow in the US and Canada in December 22, January 23. Remember?
We even had a few days of snow in Paris, but
Yeah, yeah, it is. And late snow in Australia, 22, 30 of November. It is the beginning of summer. 1st of December is summer in Australia. They had snow for a whole week. End of it's our end of May. This is
how
what
long do
they.
you think they're going to still, I suppose, deny that this is going on?
Oh, this take another 2-3 years until we start getting this regularly.
Okay.
So this would because in 2015 they were saying, "Oh, it will be only heating. There's no cold. They will not be cold." Now even BBC put blog that, "Oh, it will be cold snap end of January."
Well, the
And they
latest is
still,
now global warming is causing is causing the cold.
yeah, well, I want them to explain why the cold comes if the snow comes in May and June, and in cycle 26 after 2035 to 2045 we will have worst of it. It will be very cold. It will be like
Mhm.
in Mount the minimum there, so it will be exactly how it was then. So I don't know whether we will be. Obviously, you will be alive. You can see it and say, "Oh, I spoke with Valentina, and she told me in 2023 that it will be like
Yeah,
that."
I will keep this document, this video with the
This, yeah.
others.
Maybe I will not be alive, but at least you will say, "Look, people predicted," and it not like I'm predicting, putting the charts or calling the spirit. It is pure scientific anticipation, nothing else. So
Okay,
no magic.
so you're basically saying that we're in a cold cycle now, and
Yeah,
we
we
just
are in
have
the
to get
cold
used to it.
cycle.
We have to
Exactly.
get used to it. Yeah.
Yeah, and this ice increasing now in the Arctic even. So I'll stop this one. Bring us to the how volcanic
Yeah.
eruption will help. So volcanic eruptions, we done the paper which had a very dramatic history. It was accepted to Nature Scientific Reports. It came through the uh, proofreading. We paid publication fee, and suddenly the editor came up and withdrawn our paper that we mentioned that it will be cooling. So that is,
It seems to be this. You seem to have a habit of doing this with editors.
yeah, no, they're simply working for anthropogenic global warming people. They're
Yeah.
absolutely shameless. So we submitted to Astrophysical Journal. The same story, it came through, was accepted, proofread, and then suddenly the editor-in-chief Vishnya came back and started saying, "Oh, we don't publish this paper in the Astrophysical Journal because we don't publish statistical papers." I showed him example they publish about volcanic, but nothing worked. So they're afraid to publish the result. Why they're afraid, I will show you. So basically, these are volcanic eruptions shown by indigo line, and the black line shows average volcanic eruptions in here. We explored the dependence of volcanic eruptions on the solar cycle. Yeah, I'll skip this one. What we did when we calculate the period, we did wavelet analysis of volcanic eruption, and we discovered the most prominent period of volcanic eruption, 21 and 4 years and 55 years. So we don't know what was 55 years, 25, 21 and 4. It is actually double solar cycle. So this is
Can
why
you
we
just
compare.
explain to me how did they calculate the amount of volcanic activity in the past? The
Oh, they protocol. They have the database published in NOAA site.
Okay.
Yeah, so we took it from the known size, and from 1750. There even some data come back to the whole another 500 or a few hundred years, maybe 1,000 years backwards. But we didn't have this time. We used only the closest when we have sunspot numbers. So this is what we compared. So if you put the red is my summary curve. Remember this one which we found from the background magnetic field from principal component analysis. And the blue is the number of volcanic eruptions. So when we put them in here, so you can see that number of volcanic eruption maxima coincide with the maxima of background magnetic field when the leading polarity of the sun is southern. So basically what we found that if you compare number of volcanic eruption becomes very dramatically increased when the polarity is southern, and correlation between these 84%. So what is happening when this sun magnetic field has leading polarity southern, somehow this southern polarity interacts with the Earth magnetic field and causes a lot of geomagnetic activities. And one of them is volcanic eruptions, and another is earthquake. So, and surprise, surprise, when we have the next cycle,
So
when we have
you understand? You're saying the sun's role or solar activity can explain a mechanism for why volcanic activity would occur.
it cannot explain exactly because sun does not induce, but it creates interaction of solar magnetic field with the uh, north pole magnetic field.
Yeah.
And this creates a number of accelerated particles which jump to the earth, and obviously they affect the crust of the earth and cause volcanic eruption and earthquakes. This is what happened. So basically, solar activity simply introduces, with the southern polarity, introduces increased geomagnetic activity. And
Okay.
this geomagnetic activity causes the volcanic eruptions and earthquake.
And was this the case with the supernova as well? The
No, we don't have supernova here. It's only enough
Okay.
the sun.
Oh, okay. We don't have enough data. Okay,
Yeah,
that'll be interesting to find out as well. Yeah.
no, supernova is related only to the data to the Spur minimum, which happened in the 14th, 15th century. The
Okay.
Spur minimum 13 supernova Vela Junior happened 1380. when they restore. So at the end of 14th century, and affected the background the whole 15th century. So this is different. But
Okay.
the main thing is that the next solar cycle, when the southern magnetic polarity will be dominant, will be the next solar cycle, 26. And this is when the waves, remember, they are opposite phase. We have minimum of solar activity. And on top of that, we will have increased volcanic activity. This is why the temperature will drop very dramatically.
It's not nice to hear. I mean, it's nice to hear that you're
No, it's
correct,
very
but
nice to hear in advance and get prepared, isn't? It
yes.
would be worse if you will be thinking, oh, it will be only global heating, warming. We need to prepare the, uh, convection in the house and
So,
not
so
cold. While in fact, you need to prepare very good heating of your house. Probably replace your stove with the normal stove using the
mm,
wood and coal and so on, because you would need real heating. This is
but
what you need. I'm
I
thinking to reconstruct my house to make real stove and so
yeah.
on.
Well, I mean, people are looking at least at heat efficiency and stuff. But I've got another question for you. In the 1970s, they predicted an ice age, and that ice age's prediction date was last year. Okay, so they might have been more correct with that prediction than the global warming people. You know.
I don't know who predicted 1970. I never heard about it. People can can put a lot of predictions. I don't know. I need to look on what basis they do, because
Yeah.
we use the magnetic field of the sun, the magnetograms of the sun. I respect our method and I trust it predicts correctly. So
Mm.
this is the difference.
So you
I
can even
know,
make a right prediction for the wrong reason sometimes. You know.
yes, people can do prediction their own reason, and this is why it is very difficult to persuade other people why um, you are right and they don't, because everyone wants to be famous. So people suddenly come up, oh, it will be reduction, like Ambarasuro, it's the guy who works in the Russian Pulkovo Observatory. He now is director. He's saying that we will be having the Grand Solar Minimum lasting for 200 years, starting from maybe from last year or from whatever until another 200 years. But when you ask him, on what basis do you suggest? He looked what Eddie suggested. When Eddie was beginning of 19th century, when he discovered Mount the Minimum, they could predict. They had little knowledge and they had good imagination, nothing else to do. They can predict, you can forgive, they predicted, but we
It,
now have a lot of different.
that type of prediction is like Nostradamus. It's not really
Yes,
prediction. You know.
yes, yes,
Um,
exactly. I can wake up today morning and say, I think it will be eruption. This is the level of prediction.
that's
So
fair
this
enough.
is what I put this page about modern grand solar minimum, which is already started. And we are lucky generation which will observe this unique event from the front row and solar terrestrial connection. And
Well, I will be able to tell my children that I knew it.
absolutely,
I knew a time when it was warmer. You know.
yes. And you survive until 2053, when we become really hot and warmer.
Yeah, I will
And
be
global
63
warming
years
is
old,
real.
so I will be 63 years old then, so I will be
Oh,
able
it's
to
a good age.
yeah.
Age of people now live until 100 or 90. So you will be in the middle of your most established years. So you will be able to explain everything to your children and your pupil and everything. It will be nice. So
Somebody else asked you a question here. They said Ben Davidson has a group forecasting earthquakes using solar data. They are beginning to have some better success than chance. Do you know anything of that? That people can forecast earthquakes and volcanoes with some accuracy now?
I don't know. I didn't look at that.
No.
But the efforts the people put trying not to allow our paper to publish tells me, and we didn't do much, I would say, very much investigation. We did just comparing our data with the um, volcanic data. So nothing. We didn't. We suggested why it could be, but this is a pure suggestion. But the correlation 84% made them scared. I don't know why they become so scared, but obviously some people put a lot of efforts into quasi science because it is not a science. They put
I
something.
want to ask you on the quasi science. I mean, you did, I think last time when you spoke, you said you did your PhD on radiation transfer. Can you
Yes.
maybe explain just for us briefly why CO2 would saturate and why that,
Uh-huh.
you
Okay,
know,
we come back about
okay.
global warming. So if we come back to global warming, then I will bring you to that nice curve that after cycle 27, what we will have temperature will come back. So we will have here. Yeah. So this is cycle 27, and then solar activity comes back again to the warm. It become normal cycle, and the solar activity become increasing. Why? I think it will be temperature increasing because the global warming is real process. It defined by the temperature. Let me come back to this one where we started from. So we come to the temperature variations in here. So here, why they came up with anthropogenic global warming? Because the temperature is increasing, the solar activity started decreasing because it's coming to Grand Solar Minimum. And they said, oh, we can explain why it is increasing. It is done only by human, by CO2. This is why they came up with the CO2 and greenhouse gases, which are heating and increasing this temperature, right?
Yeah.
So this is what started. What happened? 2019, we have this formula. Remember, we have formula five, sum of five cosine functions. So we can calculate it. We use 120,000 years and calculated our formula with this light green, blue colors backwards by to 120,000 years, and then we calculated zero line. So when we calculated, for example, 2000 minus 10,000 years, if you look at these cycles, so this is my ground solar cycles, each of them. When I built them, I discovered that they every 5 cycles they have the similar shapes. And the right top with the red color. Do you see this?
Yeah.
I split them with the vertical black lines, and you can see that this first one has like increase and then sharp decrease. This one is highest, second one highest amplitude, and each one it has highest amplitude. So I found they have like similar patterns. And you think of this, I thought it cannot be random. Why do they
Mm,
have similar patterns? So we started digging in our data, and we tried to understand. We couldn't find anything in the solar dynamo theory. Nothing has been developed. No, we can find this cycle. It's about 2,000 years. We couldn't find anything. So what we did, we added amplitude top positive and negative polarity. When you add magnetic field positive and negative, if zero line doesn't change, it the summation of these two should give you zero, right?
yeah.
But when we added our baseline, the zero line started showing this nice oscillation shown by navy blue line. You see that?
Yeah. So your baseline is
Yeah, this is
good.
my baseline, which we published in Scientific Reports 2019. We started looking what is happening. Of course, the oscillations 20 times smaller than oscillations of solar cycle and so on, but there's still like waving zero line. Why would zero line would be waving? So we start looking, and indeed, this is oscillations which are often reflected in the abundances of carbon 14 isotope in trees. They have also this about 2300, 2200 years oscillations.
Mm.
So it means that solar irradiance varies every 2000, 2200 years. So this curve reminds very closely our curve. So okay, so it should be real, but what can cause it? So when we put, because we have now uh, we know what the date now, we can put this current cycle into perspective. So we put the blue is zero line for the current time. It turned out the minimum was Mount the minimum, and now this zero line is increasing towards the northern polarity. So it's
Okay.
increasing to the northern polarity. Here we are. So we thought, oh my God, what is increasing? And then when you put the temperature variation, it coincides with the temperature variation. Not only solar radiance increases, but temperature also increases. So this is why we thought it's probably because the sun moves toward the Earth.
Oh, okay. So the
So
orbital
this is why
variations takes.
we look at the Milankovitch cycle, which have much larger period. None of them were suitable. So this is why we needed to look at the solar inertial motion, which shown that all planets are rotating around the barycenter of the solar
Mm.
system. And it turned out the sun also rotates around the barycenter because of the gravitation of large planets.
But the sun, does it rotate among itself as well? I
Yeah,
mean,
this is
could
what this is the solar orbit simulator. It rotates
okay.
much smaller orbit. The orbit radius is 2 solar radius.
Okay,
It's
so it's
not.
going among itself and among the barycenter at the same time.
Yes, yes.
Okay.
And because it goes around the barycenter, so basically your sun is sitting not simply in focus, but it moves. So in the current millennium, the sun moved from the focus closer to the Earth in this spring equinox for the northern hemisphere. So this is
Yeah.
what we suggested at that time. We didn't calculate it. In that paper, we suggested that the sun moves closer to the Earth, and this is why the solar radiance increases with this period 2000 years. For
Would
that, they
the days of
retracted our
the
paper.
okay, so they said you messed up the. So the argument was you made a mathematical error on the
Yeah, they say that
geometry.
the Earth should be coming with the sun and wouldn't move. But in a year, I've proven them wrong, and I'm right because I published the chapter in the book. I took ephemeris of the distances, sun-Earth distances, from 600 to 2600 years between sun and Earth. And I shown that this distance is decreasing. You see, this
Yeah.
is in 600, 1600, much more decreasing in this millennium. So in the millennium previous one, decrease was only 0.05 thousand astronomical unit. But in this millennium, for example, in April, the decrease is about 0.11 thousand astronomical units. It's a large amount. Furthermore, the solar solstice, for example, if in last millennium it was 21st of December, remember by astronomy, the
I was
21st,
about to ask you that if the solstice and the equinox is shifting.
they changed.
Yeah.
So in last millennium it was 21st of June, the summer solstice. In this millennium, and in this year, for example, in 2022, and this year, the actually solar solstice was 5th of July.
Okay.
5th of July. And in 2600, the solar solstice will be, and this one on the 16th of July. So it means that the sun closer to the earth at the period when we have summer in the northern hemisphere and it gives much more radiation to the Earth. And I'll calculate it. So here is how the distance changes in last millennium, when you have the longest distance summer solstice in June. But in this millennium, the longest distance is actually in July. And this is why this extra month of heating gives us the extra heating 20-25 watt per square meter for the whole planet, or 10-12 watt per square meter for each hemisphere. This is the one. So basically, because of this solar inertial motion, these guys, Rice and others who pretended that I did some error, I use ephemeris from official site, NASA site and Paris Meudon Observatory sites. So they are wrong, not me. I wrote then letter to the dean of Rice in the Edinburgh University saying, either your professor doesn't know celestial mechanics, or he deliberately mislead the whole community and lying
or
about.
he read what he wanted to read, you know.
Yes, exactly. It is absolutely incredible that people pretending to be professors in celestial mechanics do such basic mistake. It was their job to check ephemeris official. It's not done by me. It was done by official site. I downloaded simply when we got. They retracted my paper 4th of March 2020, and 23rd of March they put us on the lockdown. So I was sitting half year, or at least first month, sitting and thinking what to do. Instead of pitying myself, I said, okay, let me check who is right. So I downloaded all the ephemeris for the every day for each year, which I mentioned, and then started building the plot. It took me 3 or 4 months to download and process it in Excel. And then voila, I found that our anticipation was correct. What I found is the calculated solar radiance for each day for every year. This in this book, I'll give you at the end the link to my book. It is freely available. Everyone can download.
But can everyone who read it understand it?
Yep, it is.
Okay.
If you have difficulty, you can read only section 5, which describes interaction of solar activity and the orbital motion of the sun. So it's simplified version of it. So basically, what I shown that here is the solar radiance coming in the previous millennium from 600 to 1600, and solar radiance coming from 1600 to 2600. So you see it is increasing until 2400, maybe 25. So we will have increase. It doesn't matter what we do. We can reduce carbon, we can reduce whatever, all greenhouses. It doesn't matter. The sun moves closer to the earth because of this inertial motion, because of the gravitation from Jupiter, Saturn, and Uranus, and Neptune.
That's because Jupiter, they are much more bigger planets, so they pull.
Yes,
they pull.
because when they invented Kepler law were produced. Copernicus was done his theory end of 15th century. Then Kepler, 16th century, he put forward. And 15 years later, only after Kepler laws, Newton discovered gravitation. It took another 300 years until 1965, Jose calculated backwards effect of planets on the effect of the sun and found this solar inertial motion. The solar inertial motion found on this 70 years ago.
I'm curious, what happens to the solstices and the equinoxes if Milankovitch occurs during a Milankovitch cycle? They would also shift further.
Oh yeah, these are different. Milankovitch cycles, they include inclination of the Earth axis. So the more axis is inclined toward the sun. At the moment is 22.5 degrees. We can have 24 or we can have 21. If 21, the difference between north and south will be much less, because, but you see, the main radiation comes when our pole on the north is inclined towards the sun. This is when we have summer in the northern hemisphere.
Yeah.
And when the southern pole inclines towards the sun, when they have summer in the southern hemisphere. So if this inclination stronger, then we have longer summer because more part of the earth will be exposed to the sun. With inclination is decreased, we have shorter period covered by the sun, and we have colder summers. So this period normally, one of them 15,000 years, another is 41,000 years, but none of them compared with the one I'm speaking.
Yeah.
It different cycles. Plus the orbit eccentricity can change. So at the moment it is about 0.067 or something. It can slightly increase. It means that the spring and autumn equinoxes can become closer to the earth and
So
get more.
it goes from cylindrical to spherical to circular. It moves in
Yes,
the circular
exactly.
direction. Yeah.
If orbit is circular, then we don't have much difference between winter and summer. But the more it become elliptic, we will have this difference, which part of the planet is turned to the sun, so kind of thing. So anyway, this is what we managed to actually prove, that they retracted our paper without any reason, only because AGW people asked them, because they didn't include this mechanism into their models. But on some reason, they should include some wrong mechanism. If this mechanism is working, then their mechanism is not working. Why it is not working? So I needed to dig on this. This is why my knowledge of radiative transfer helped so much.
Which
So
just for just to again for the listeners, you did your PhD in this subject. You're not
yes,
making
and I
this
did
up.
PhD actually for radiative transfer in solar prominences and measuring different radiation of H alpha to Lyman alpha line of hydrogen. We managed to extract half filamentary as those prominences to the line of sight. So I knew the radiative transfer at very deep level. It took me 5 years to master it, but I managed eventually to do it. So sorry, I'm drinking water.
No, it's not a problem.
thirsty.
The audience and people are enjoying this conversation. So
Okay. So what is happening? So I thought, yeah, well, probably should show this first. So first of all, let me show you that the main emission, this is the spectrum, visible spectrum of the sun.
yes.
So this is irradiance coming from the sun, about 2 watt per square meter. Invisible spectrum, orange emission. And this is the emission of CO2 infrared spectrum, which is order of magnitude, if not 2 order of magnitude lower than the visible. But the main heating comes from UV emission, which is not visible, which atmosphere cuts from us. The UV emission hits the troposphere. The main sun comes, the main energy comes from this UV emission.
Yeah.
And what they said, that this emission hits the Earth, which is 10th of the visible and 10 minus 4 of the UV. I couldn't believe it. This is my
It's a very narrow band of the entire spectrum.
yes, and the energy of CO2, you understand, hash nu, this is the energy of emission. If invisible spectrum nu has very high numbers, thousands of hertz of some, but in here nu is very little. So this hash nu, the energy emitted by CO2 is so small that I wonder how could it hit. So you look then, what people did before me, Chandrasekhar, Kondratiev, They evaluated the people, some who do observe CO2, they evaluated the optical thickness of CO2 and methane, CH4, in the
You can't even see methane there.
methane is not there, but this is why they stick to CO2, because its optical thickness increases to 400, which means that you have 400 more molecules compared, let's say, to normal distribution. So what is optical thickness? It's number of atom on the line of sight in one, on the square 1 cubic centimeter, multiple by absorption coefficient. So if absorption coefficient 10 to minus 8, then you have to have 10 to 8 particles to get optical thickness 1. Or you have to have 410 to 8 particles to have optical thickness 400. What this guy said, indeed, the number of CO2 increases, and it keep increasing since they started measuring. It's true. But when it is increases, what they did, so the intensity of the emission is described by this formula. E2 is actually exponential function.
Okay.
So I will skip this one to tell you on the fingertips. The intensity, how they measure, they said, okay, we have 4 times more number of molecules of CO2. We add all intensity from each molecule, and this gives them the total intensity, which comes from the layer where the CO2 is emitted. Understand this, yeah?
Yeah.
So they added everything together, while it is not allowed. Radiative transfer. So if you have this is the gray box, this is the solar radiation with this black line. Gray box is your CO2 emission, and red is what is coming out from that. So if your optical thickness is less than 1, you indeed can add any emission from each molecule add together, because resulting emission is proportional, linearly proportional to the optical thickness. When optical thickness less than 1. But when optical thickness become greater than 1, what we got? We got diffusion, absorption, re-emission, absorption and re-emission. So we got a saturation. And when the optical thickness increase much greater than 1, we got this red curve. The emission coming out of this gray box actually is saturated, and saturation come at the emission and optical thickness 1. So basically we see only emission from the narrow layer from each side, and whatever happens inside we cannot see it until the top emission comes up and this emission comes closer. It is like if you go on the football pitch, people standing on the field, and suddenly you have the fire. They all want to go out from the pitch, but they cannot go out because they have only one gates to go through. Gates can allow to go 100 people per second. So the first few thousand, they can see how they go out, but those who are far away from the gates, they don't even see. This is how radiative.
You have a bottleneck. You can't get more out of it.
Yes, exactly. So these guys basically applied their own theory. They added all the emission of this CO2, while because of the radiative transfer, they should have this saturation. And this guy, Hardy, one guy, once he put some radiative elements of radiative transfer, not even whole of it. He added extra layers, but he increased radiative input to 5 watt per square meters. And when increased, he found that 60% would be caused by this radiation, and only 40 by CO2. but he still didn't consider it fully properly. But remember, I said that my radiation increase is 20 watt per square meter. So
It's 5 times.
basically, it's
5 times.
100% come from the sun.
Okay,
And this is
but the
what,
other argument that they make is they say that water vapor will be a feedback. So they accept the saturation, but then they say because CO2 and water vapor overlap in the band, it's actually the heating is going to come from water vapor. Now that to me has never made sense because
no, no,
increased
no,
water
no.
vapor has more precipitation.
Exactly. Water vapor come the water vapor, it is not heating. So we now have this source of the heating. We have the sun which moves. It's a huge boiler, which huge heating comes up closer by 0.11 astronomical unit closer to the Earth. Imagine this heater comes to us. It's only sun come heating us. And okay, we have heating, global warming now. The sun is close as it, but the sun comes now into grand solar minimum. So if it comes into grand solar minimum, then the actually solar radiance will be reduced because of that, right? And because of that, solar reduced and the temperature will reduce. And this is what we exactly observe. So if we observe grand solar minimum and not global warming, then the sun is the main source. And the global warming is caused by the sun because it moves in this solar inertial motion and wobbling orbits. And by the way, if you look at solar inertial motion, you can look that actually astrophysicists, they look for the exoplanets based on the fact that the star has wobbling radiation. They know if the star has wobbling radiation, it must have the planetary system, and then it's very high chance it has planets like we have on the Earth. So the astrophysicists knew it. The solar physicists before whoever consulted IPCC knew it, and suddenly they pretend they don't know it. It is well known fact. It is well known fact. And if the sun will start decreasing radiation and temperature start decreasing, we have exact evidence that nothing comes from anthropogenic global warming. Everything comes from the sun. And the sun, when it moves back to its focus, when the inertial motion stopped in 2600 and the sun starts moving backwards to the focus of the to the barycenter of the solar system, all the solar activity returns back and it starts cooling off after 2600. But before 2600, the temperature will be increasing, and what I calculated, increase will be for another 2.53 degrees. So we have to prepare ourselves after 2053 to further increase of the temperature and then take measures. But this is nothing new. When Roman Empire was in Scotland and England at the beginning of Anno Domini in 300, 400, they had grown the grapes in Scotland. They had Roman baths in Scotland, so it was very hot there. So it was 2000 years ago, exactly as we predict.
But also, I mean, this is an argument that Richard Lindzen gave me, which was the the heating will not also be uniform on the Earth. You know, they acting as if the entire Earth's going to heat up, but it's generally in the extratropics. In the tropics, you know, the greenhouse effect is maybe more prominent, but you have much less differential there. So, you know,
Exactly.
this
It
thing
needs to be
doesn't add up.
calculated.
Yeah.
It needs to be investigated. Luckily, the sun gives us 30 years to put in order. It gives us cooling off. Yeah, cooling off. We need to work about build greenhouses because we need vegetables, we need fruits, we need to feed us, we need to feed animals. So either build something in Africa, which the only continents will not affect it will be those below close to tropics. They will grow up food and everything. Or we need to build greenhouses in the northern countries to protect ourselves. So we need to think through this. And over the 30 years, then we need to think how to cope with the increase in temperature if it is outside our control, if Romans managed to deal with it, if other people in the Europe and America managed to deal with all our technology, would be able to deal with it as well.
Yeah, I mean, I've never seen a reason why we can't adapt, even under catastrophic conditions. So it's just absurd.
Yes, it
Um,
is. We have all the devices available. We only need to apply them with the reasonable, logical approach, and not uh, trying to adjust some ideas of crazy people who wants to be famous, or who seen too many films on the Star Wars and want to glorify themselves as the savior of the planets without real reason. This is
yeah.
what we need to start thinking logically, and not trying to uh, satisfy the ambitions of some people.
Mm. I have a last question for you because we really have. I would like to thank you first of all for this long discussion you've given me. The future research that you're going to do in this area, where are you? What are you looking at the moment that we can
Oh,
maybe
we
get
try
excited about?
to publish the papers on the volcanic activity and comparison, and we try to compare the effect of this solar inertial motion on the northern and southern hemispheres, because they definitely have differences. Even these 2000 years, we seen that actually they recorded the coldest winter during our summer, record this winter in Antarctica. It was the coldest temperature they ever recorded. So obviously it will be warmer for this cycle on the northern hemisphere, much colder in the southern. So this needs calculations. We started doing some, but haven't yet. We need to finish some other job, but need to do. Also, I need to find funding, because I need to. Um, when I try, people do some calculation for me, I need to pay them. Not only
You should put in your proposal global warming for the sun or something, and then they will give you funding. You know.
yes, I had funding. I had my own company still half year. The funding is here, but for after that, during the half year, I need to find further funding. So my collaborator, I try to pay, support them, because it's very difficult life everywhere. Uh, Crisis with the energy resources and idiocracy. They try to put everything electrical, which is extremely expensive and absolutely inefficient. So I hope we can survive this and start working normal. What encouraged me, I heard Elon Musk with the SpaceX, they put on the orbit Ukrainian satellite, in which
Mm.
will be measured the variation of solar radiation during the motion on the orbit. So, because my research was the first who brought to their attention that variation of solar irradiance while the Earth moves on the orbit defines this difference in, because so far they take solar radiation as the average for the whole year. So this is what they do. Average for the whole year. This is why they missed the input from the sun into the models, because they do not consider solar input properly. So now Elon Musk wants to measure this. Maybe he read the book, the chapter, and can
Well, I hope
measure.
so. I hope all people look at your research anyway. Anyways, I'd like to
Yeah,
thank
I
you.
will
But
show you
yeah,
picture where the is my uh, chapter, so you can take the
yeah,
address.
I'm gonna put the book in the description as well. So because I think there's gonna be people that would like to buy it and inform themselves. So
Yes, it is a nice. Basically, what there is my. Yes, so the website https solargsm.com, and Let's come try this one. No, I don't want that one. I need to find the
link is.
No. I need to find Chrome. Not this one. To find another Chrome. Because I. Okay, let me do this one.
There we go. You're the host of that website? Yeah.
Yeah, this is my website. I remove publication because it has. So you come. This is the website you want to have.
Mm-hmm.
And then under this website, you have home, blogs, where you can read if you want any plots about volcanic eruptions or comparison. Everything is here. My interviews are also, after you publish, I will give a link. And plus, I have publications in here. And this book chapter published 2021, here called Millennium Oscillations. So this is in my, so this is in the book. So you go there, download chapter, and can buy the book as well. So
okay, that's
so
interesting.
it is
I
freely
hope,
available to download, and if you want to buy the book, you can buy the book. But everything I spoke today, I put in here with the plots, explanations. So given this manual with the presentation, the book should be much more clear for the readers and for yourself.
Okay. Oh, thank you again very much for this chat. And
Okay.
yes, I think maybe next time we have another publication, next year, the year afterwards, we do this again. And I really enjoy this. Thank you.
Yes, yeah, you're very welcome. And I hope we will see the Grand Solar Minimum for the whole 30 years. And then you will see increase of the temperature and enjoy nice warm weather. Okay, cheers. Bye-bye.